Hi everyone, welcome to Cloud Computing series. In this video, we'll be learning about peer-to-peer network families. See, normally in a network, there are two types of computers, clients and servers. The server gives the services and the client asks for them. Your personal computer or office workstation connects to a powerful central computer to get files, data, or services. Then we use a client-server network every day, like checking emails, downloading files, or using apps that fetch data from a server. See, unlike a client-server, peer-to-peer is a different way of connecting computers. There is no single central server controls everything. Then it is a distributed model. That is, in a peer-to-peer, work is spread out among all the computers. Every computer shares some work, so no one is only a user or only a provider. Instead of depending on a big server, peer-to-peer focuses on individual computers helping each other directly. Then each node acts as a both client and a server. Means every device in a peer-to-peer network can ask for something and also provide something to others. It behaves both like a client and a server at the same time. To understand peer-to-peer networks better, experts look at them into two ways: how the machines are physically connected and how they behave logically. This means checking how cables, Wi-Fi or hardware connect the devices physically. Then second one is logical level. That is how peers organize and communicate logically over the network. Means seeing how the devices interact, share resources and manage connections even if they are far apart. Moving to the next. In a peer-to-peer network, each computer both uses resources and shares its own resources like a network speed, files or a storage space. Then peers are ordinary client computers connected via the internet. Means peers are just normal computers that connects with the other computers over the internet. Then nodes can join or leave the system freely without affecting the entire network. See, any computer can join or leave the network at any time and it won't break the whole system. The network continues working normally. Then there is no master-slave relationship. In a peer-to-peer network, no computer is the boss or a controller. Every computer is equal. No one controls the other. Then no central coordination or a database is required. Means there is no need for a central server to manage or store everything. Each computer manages its own information. Then next, each peer has only local knowledge, not a global view of the entire system. Means every computer only knows about a few other computers nearby. Doesn't need to know about all the computers in the whole network. Then the system is self-organizing with a distributed control. That is, the network arranges itself automatically. Control and decision making are spread across all computers, not just one place. And moving to the next topic, that is overlay networks. See, an overlay network is a virtual network built on top of a real physical network where devices connect and communicate using a special software, not a direct physical links. And this diagram shows a peer-to-peer system works using an overlay network. At the bottom, devices are connected physically through an IP network like using routers and cables. And at the top, the same devices are connected in a virtual way. That is overlay network using a logical links. These virtual links are not based on a direct physical connections, but they are created by the software to allow peers to communicate easily over the internet, no matter how they are physically connected. The next is, in a peer-to-peer systems, data or files are distributed among peers. That means in a peer-to-peer network, the files and the information are shared between computers instead of being stored in one central server. A logical network called an overlay network is formed based on peer IDs and communication needs. That is, special kind of network, that is the overlay network, is created where peers are connected based on their names or IDs and how they need to communicate. Then this network is a virtual and built on top of the physical connections. That is, the overlay network is a virtual and works using the real internet connections underneath it. The next is, yes, say when a computer joins the network, its name or ID is added to the list. When it leaves, its name is automatically removed without disturbing others. Then the overlay network shows logical connections among peers, not physical links. Yes, the overlay network only shows who is connected to whom logically, not how computers are actually connected in the real world. Then the types of overlay networks. The first one is unstructured overlay. See, unstructured overlay forms a random graph, that is, peers connect randomly without any specific order, like people chatting in a crowded room. Then no fixed routing often uses a flooding to send queries. That is, there is no fixed way to find a file. The request is sent to many computers, hoping someone has the file. Then unstructured overlay causes high traffic and non-deterministic search results. Means this creates a lot of internet traffic and may or may not find the file you are looking for. Second type is structured overlay. See, this follows a defined topology. That is, peers are arranged in a clear pattern like a ring or a tree structure. Then it uses a specific rules for adding or removing peers. That is, there are strict rules about where or how new peers can join or leave the network. Then in a structured overlay, efficient routing is possible due to structure. Because of a neat structure, it's faster and easier to find files with a fewer messages sent. Then moving to the next topic, that is peer-to-peer application families. Say, peer-to-peer networks are used for different types of activities. Based on what they do, we can divide them into 4 big groups. The first one is distributed file sharing. It is used to share digital content. Means people use peer-to-peer networks to send and receive files like songs, movies and programs directly between their computers. Then popular examples are Nutella, Napster and BitTorrent. These are the famous peer-to-peer platforms where users can easily download or upload files without needing a central website. Then second category is collaboration applications. See, it supports real-time communication and teamwork. These peer-to-peer apps let people talk, chat or work together instantly over the internet. And examples include Skype, MSN chat, and collaborative design tools. Apps like Skype allow video or voice calls. Then MSN chat helped people message each other. Then design tools help teams build project together while sitting in different places. Then the third category is distributed computing. See, it uses ideal computing power of peers for large tasks. Means that is, peer-to-peer networks can gather the unused processing power from many people's computers to solve very big problems like analyzing space signals. For example, SETI at Home is a project where millions of people's computers helped search for signals from aliens sharing their free computing power. Then the fourth category is general peer-to-peer platforms. See, they provide core services like naming, discovery, communication and security. Some peer-to-peer platforms are built to give basic services that any peer-to-peer app needs, such as helping devices find each other, communicate safely, and manage user identities. Then examples of this are JXTA and Microsoft.NET peer-to-peer and Pydates at Home. See, platforms like JXTA and Microsoft.NET peer-to-peer offer a basic building blocks for creating other peer-to-peer apps. Then Pydates at Home uses a peer-to-peer computing to help scientists find cures for AIDS. Then moving to the next subtopic, that is peer-to-peer computing challenges. See, peer-to-peer systems face some problems that make them hard to use in the real world. is heterogeneity issues in this hardware. Let's see, different computers are a part of the network which can cause problems when they try to work together. Then software incompatibilities between operating system and applications. That is, peers may run different operating systems and apps that don't always work well with each other. Then networks, diverse protocols and connection types, means different peers use different types of internet connections and network rules, making communication tricky. Then scalability and performance, needs to handle increasing workload and maintain performance. Means that is, as more people join, the system must still work fast without slowing down. Then performance is linked to bandwidth, routing efficiency and self-organization. Then next is data locality, in the sense data should be close to where it's needed. Yes. Then network proximity is nothing but connected efficiently and work well across different devices. That is nothing but interoperability are key design goals. The next is reliability and fault tolerance. See, no central point, because there is no one main server. The network is strong and it won't break easily if one peer fails. Then data replication helps avoid loss from node failures. Copies of important data are kept in many places to prevent loss if one computer goes offline. Still, managing a decentralized system is difficult. See, managing many independent peers without a central control is very hard. The next is security and trust issues. So peers are unknown and untrusted. You won't know who is in the network, so it's risky to trust them. See, risk of security breaches, data misuse and copyright violations. Because someone might steal data, spread viruses or misuse copyrighted content. Then yes, see, anyone could intentionally or accidentally harm the network by sending bad files or attacking systems. Then when is peer-to-peer useful? See, best for low security needs. It works well when the information shared is not sensitive or a secret. Then suitable for non-sensitive data and limited peer nodes. Peer-to-peer works better when fewer people are involved, making it easier to manage and safer. Thanks for watching. If you found this video helpful, don't forget to like, share and subscribe for more insights on cloud computing, and also check out our playlist for more in-depth topics. See you in the next video.